Now let's explore finding the perimeter and the area on the coordinate plane. And so we're told here that we're asked to find the perimeter and area of triangle ABC with vertices of A is -1, 4, and B is -1, -1, and C is 6, -1. And before we move over to a piece of graph paper that I have behind this, where I have plotted these vertices A, B, and C, I want to remind you of a couple of things. One is our distance formula. And if you recall, we can find the distance on a coordinate plane, x2 minus x1 squared plus y2 minus y1 squared, and then take the square root of all of that. That is our distance formula. Also, another one that I'm going to remind us of that we're going to use, if we've got a right triangle, and we can find either a leg or the hypotenuse using Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. Now also, we're going to ask to find the perimeter. Well, there, once we get the measures of each of the three sides, and we know we're dealing with the triangle here because we have three vertices, well, we just add those up and that gives us the perimeter. And to find the area of a triangle, well, we know that the area is equal to 1/2 times the base times the height. So let's move over here to a piece of graph paper. We got distance formula, we got Pythagorean theorem, we got the formula for the area. The perimeter, we just add the measures of the distance of the sides. So now here on this piece of graph paper, which I did in GeoGebra, and I plotted the vertices. Here is the A vertices, which is -1, 4, 1, 2, 3, 4, -1, 4, that's the A vertices. The B vertices is x -1, y -1, -1, -1. And the C vertices is 1, 2, 3, 4, 5, 6, x6, y -1, so it's 6, -1. Now, if I look at this triangle, and there's other ways we could prove it by finding the slopes and so on and so forth, things that we'll actually work with later. But I'm going to then say that this is a right triangle, which means that we've got two legs, and this is the hypotenuse directly across from the right angle. Now, in terms of finding the distance, well, in this case, and since I've got it on a coordinate plane, and I could use the distance formula, let's say for this leg, which is labeled as F, but since these fall directly on a grid line, I can really just count. 1, 2, 3, 4, 5. So this is 5 units. And G here, this leg, I can count again. 1, 2, 3, 4, 5, 6, 7. That's 7 units. But I can't count this segment AC, or which is labeled here as H, because it doesn't fall, even though the endpoints fall on a grid line, it's not a straight line. It's not either a vertical or a horizontal. If it was vertical or horizontal, I could probably count, but it's not. And so since I know two of the legs, 5 and 7, I'm just going to use Pythagorean, which would be, if you remember, a squared plus b squared equals c squared, where C is the hypotenuse. So then we're going to say 5 squared plus 7 squared, those are the measures of my two legs, equals C squared. Well, 5 squared is 25, and 7 squared is 49, and that equals C squared. And 25 and 49, 5 and 9 is 14, carry your 1, 2, 4 is 6, plus the 1 that we carried is 74. That equals C squared. And so C is equal to the square root of 74. And so this distance then is the square root of 74 of that segment AC, air conditioning, AC. All right, and then I may want to think, can I simplify that? And I'm just going to go through an exercise really quick. Let's see, take prime numbers and square them and see if they are divisible into 74. So let's see, 2 is a prime number, 2 squared is 4. 4 into 74. Well, 4 times 12 is, excuse me, 4 times 16. 4 times 16 is 64. No, that would leave 10 left over, and that's not divisible. Let's try 3 squared. 3 squared is 9. Well, 9 times 8 is 72. So that's not going to get me to 74. And 5 squared. 5 squared is 25. Well, 25 times 3 is 75, but not 74. And what else? Let's see. I guess I could try one more. 7 squared. 7 squared is 49. But 2 times 49 is going to be 98. Okay, so I think the square root of 74 is as simple as I can get it. Now, to find the perimeter, I can just simply take these legs and add them together, and that will give me the perimeter. So I got 5, not just the legs, but all the sides. 5 plus 7 plus the square root of 74. And 5 and 7 I can simplify. 5 plus 7 is 12. And so the perimeter is 12 plus the square root of 74. And I could probably get a value for that on the calculator. Let's see. 12 plus the square root of 74. About 20.6. So the perimeter is approximately 20.6. All right, well, what about the area? Well, the area is 1/2 the base times the height. And if I'm looking at this, well, my height would be 5 units. My base down here, let me put this in a different color. My height right here is 5 units. My base is 7. So we're going to say the area of this triangle is equal to 1/2 base times the height, or 1/2 times 5 times 7. Let's see, 5 times 7 is 35. So the area is 1/2 of 35. And 2 will go into 35. 2 into 3 one time. Carry the 1, got 1, and then 2 into 15. Well, 2 times 14 is 7. And I got 1 left over. Or 17.5 units squared. Units squared. And up here, my perimeter is just 20.6 units, although I don't know what those units are. Having a piece of graph paper sometimes can save you some time. Not always, but sometimes. And plus, it's fun to do. And I like to have fun. Do you like to have fun? Do you consider this fun? You probably have to be sick to consider this fun. Okay, well, enough said.